I need to configure the LED built-in. The LED built-in is assigned to this port, the 17 port. So it is a specific macro. So how you can see, I use the LED built-in. I'm trying to configure this 17 port like output, right? So I'm trying to configure the LED built-in like output, and the initial state is low. And with this, I have all the digital ports like outputs, and the input ports are configured with this trace command, or with these trace functions. Pin mode, button 1 like input. So if you can see, I should say to the compiler that I want to use the mode of the use of the pin. So the LED built-in is used like output, and the buttons or the digital ports that I want to read the state of buttons, I want to use it like inputs. So the button 1 or the 12 port, the 12th digital port is configured like input, the button 2 input, and button 3 input. So if you can see, is the use of macros is the easiest way to configure all the ports, and it's a compact way to set the initial state of these ports. Well, the lock function is like a while loop with a one condition. So this loop, how is written in typical microcontroller programming, is something like this. It's a while loop with a 1 or with true, and this is an infinite loop, or with for loop. We can write the for loop with this representation of 4, infinite 4, without condition. So never end, right? So I use the for loop inside this loop, right? That's the difference between another programming technique with another microcontroller, but it's the same. Well, the for loop, or this loop function that is used in Arduino, do the same function. Well, an infinite loop. So this function is a little dense, but I will show you the code that I wrote inside here. Well, I will start with this conditional, with this if condition. What I do this, or what do I here? The millis function return the milliseconds after of turn on the Arduino device. So when I turn on the microcontroller, the millis return the amount of milliseconds since I turn on the device. Use the timer, internal timer, so it function give us only the execution time since I turn on the microcontroller. Well, so I need to use the first of these variables. I have many variables, but I'm going to explain it in the way that I'm using it. So millis give us the milliseconds, right? Time is a long int variable to compare with the amount of milliseconds since I'm sensing the time. So if I call this millis minus time, and time, the initial state was 0 when past 250 milliseconds minus 0, that is the initial state, when it's greater than 250 milliseconds, I can to input to do the conditional, right? So millis 250 well, should be 251 minus 0 give us 251, that is greater to 250. So if I do this, 251 greater than 250, right? That condition is true, so I can to do inside this conditional. And what I do, assign the milliseconds, the current milliseconds, to the variable time, right? To the another verification in the iteration after of this. So I'm inside of this conditional because this condition is true, right? What should I do? Verify if I pressed the button 1, and this variable button change is equal to 0. Button change correspond to functions for button true. So this condition tells us that if I've pressed the button 2 and I press for first time the the button 1, so I'm going to turn on the display because I have an increment of this variable button set hit here. So when I press one time the button 1, turn on the display. That happened in this execution. I show you. So when I turn on the microcontroller, so each iteration of the loop waits 250 milliseconds to check the state of this button. So if after of 250 milliseconds I press this button, so I enter to this condition, and what happened? Turn on the display, because how I shown to you before, the LT port, the BI port, and the LE port are set to 0. We have the lamp test, and the lamp test is turn on all the display, right? So if I press the button a second time, what happened? I'm going to press a second time. Look, that the system turn off all the 7-segment displays. And what's the reason to this? Because I have here the blank condition that gives us the truth table of 4511 integrated circuit. If I put 1 in the lamp test port, I put it in 1, and BI and LE in 0, I have the 7-segment display turn off. And if I press for 3 times the set button, I'm going to do the transition here. If I press 3 times, what happened? Keep turn off the 7-segment display, right? But I turn on the dot point. That's the function, or that happened when I press the button set 3 times. Look that I have multiple conditions here. When I press 1 time, turn on all the 7-segment displays, but that's done because I use the control ports, right? The LT, the BI, and the LE port. When I press 2 times, I turn off. How? Sending 1 to LT port. And to configure my function that is represented by the button 2, I should turn on this dot point segment that happened here. So I keep turn off the 7-segment display except the dot point. That's the reason, because I keep this configuration, but look, the same configuration, turn off all the 7-segment display, and only I turn on the dot point. Remember that this dot point is not controlled by the 4511 integrated circuit. I control this port, or the dot point segment, by a digital port of our microcontroller directly. That's the reason why I can keep the 7-segment display turned off, but I can turn on the dot point. To do the configuration, give by this button 2, right? Well, so I wait 250 milliseconds. I should wait for the condition that I press the button 1, and obviously that I never press the button 2. So I wait for press the button 1, and if I press the button 1 time, turn on the display with these instructions, turn off the display with these instructions, and keep turn off all the 7-segment displays, but turn on the dot point segment to configure it, the initial count. That's the reason. And by default, because the if instructions have a default, by default, and that default is after that I configure. So by default, the 7-segment keep in this state, but I turn off the dot point segment. Right? That's the work of this conditional. So this conditional is until here. That's the bracket. Here is this conditional to operation of button 1. Well, the button 1 obviously to the configuration stage. So I'm going to indent. What happened here? Here is the step when after of configure the initial count, I use the button 1 to start and stop the count, right? So I use the button 1 for 3 functions: start the system, or turn on all the system, turn off all the system, for configure and allow that button to set the initial count, and after of I start the count, the button 1 is used for a stop and restart the count, or no restart, continue the count, right? So that's the meaning of this conditional. If I'm counting, so I can continue or stop the count. That's the meaning of this conditional, right? That's all the work that should do the button 1. What happened with button 2? Well, button 2, when it's pressed and the button set is pressed 3 times, only in this case when button set is in the state 3, so we can see here, only when the button set, right? Remember that when dot point is turned on, I can configure the initial count. So I'm going to do this. Check that the initial count is 5, 10, 15, 20, 25. And another thing, what's the reason that I'm trying to set 250 milliseconds to wait until one button is pressed? Because like many systems, if we keep press the button, we can automatically increase the count. Increase the count every 250 milliseconds or every press of button. 95, and again 5 seconds, 10 seconds, 15, 20, etc. I can use one press, or if I keep press the button, he continue increasing the count, right? And if I reach the 95 number, restart the count, obviously, to the 5 seconds, right? 10, 15, 20, 25, and in this point I can start the count. Obviously, I can stop, or I can continue the count, right? After all of start the count, I cannot to again configure. It's not possible. I should to reset hold the system, and I cannot to establish the initial count if I'm not in the set state. Look, I cannot to configure the initial count. Only in this configuration state that is given by the dot point turn on, only when it's turned on I can configure. Right, so I'm going to reset, and I'm going back to our code. That's the reason, only when I press the button 2, but if beside I am in the set, or the button set is pressed 3 times, only in this case I can configure the initial count. Another way is not possible, right? So when I press the button I can establish the initial count, right? So I use the function button 2 to establish the initial count. So if we go to the function button 2 that is here, look, this function, what do the function button? Right, turn on the display, obviously turn on the display, because the previous configuration always the 7-segment displays are turned off, so I should to configure it and turn on, and that show the number that I want. So initially 5, so I use 2 variables. Why 2 variables? Because with this I control the 7-segment display that is located to the right, and this the 7-segment to the left. These variables are declared in this part here. This U control the 7-segment display to the right, and count the 7-segment to the left. External for loop, when J is 0, controls the left 7-segment, and when J is 1, controls the right 7-segment. So this for loop, in the first iteration J is 0, right? When J is 0, I execute this internal for loop that goes since here until here. So what should to do? If J is equal to 0, I need to activate the transistor, this transistor. I will show you. I should to activate this transistor, right? So I activate the 7-segment display that is located at left. Well, I activate the 7-segment display, and I write in the digital ports. So that's the reason, because I use 2 vectors. This is to give to this function digital write what port I want to activate or not. But the function digital write receive the port number and the state that could be high or low that receive this function digital write. So control port 7seg, what contains this array contains the ports, the input ports of 4511 integrated circuit, right? So that happens here. I have an internal for loop that goes zin 0, 1, 2, 3, and in order of ideas, each loop return the port corresponding to D, corresponding to C, corresponding to B, corresponding to A, and this array what tell us? This array is the matrix, this matrix, this one. So what happened? If I return, for example, a 0, this matrix is or have dimensions of 10 by 4. So each row the index are index 0, index 1, index 2, index 3 for rows, index 4 until index 9, and correspond obviously with our representation of binary numbers. I can see that that is the main reason to select a matrix or two-dimension vector to represent the input data to the integrated circuit, because each row corresponds to our code to send to 4511 decoder. So if I select, for example, if cont U are 5 and cont D are 0, that represent the initial state of 5 seconds in the initial state of our countdown. So what happened here? If we see output 7sec cont D are 0, so here we have the row 0, right? The row 0 have assigned the 0 value. So the only thing that I need to do is iterate over each port, and that's the reason because I have this internal for loop, because I pass over each port and assigned each of this state give for this number. For example, this number is for tens. So if I configure 5 in the units and 0 in the tens to represent 5 seconds, so here I have 0 and here I have 5. Why? Because this conditional is the complement. This part of the conditional for tens and this part of the conditional for units, talking obviously with regard to the 7-segment display, right? So after I configure the tens 7-segment display or a 7-segment display that is located at left, I should configure the right 7-segment display. How? Turn off the first transistor and turn on the second transistor. We see in the diagram we should to turn on this transistor and turn off this transistor to configure this 7-segment display for the units that I want to configure in this conditional, this 7-segment display, right? So I should to turn on this transistor to configure this and turn off this transistor. Remember that I shouldn't to turn on 2 7-segment display at a time. Is one or the another one, but not 2 7-segment display at time turn on. Should be turned on, right? So that's the behavior that I trying to represent in this conditional and in these for loops. Assign the representation of our number in the initial count and switching between 2 transistors here and here, because I'm doing a switching, and every 10 milliseconds I'm switching, because I don't know, we have the illusion that are turned on at time, but it's not true, because we are doing the switching each 10 milliseconds, so it's so fast and we cannot to see in this velocity. So that's possible for that reason, because it's so fast and faster that our eyes can't to distinguish between these two states, right?